Okay, so I'd like to sum up a few things about vectors and list. So you should be conscious that string, even it is assigned to represent text. Behind the scene, string is a vector of characters, so it behaves the same like vector of cars. Yeah, so there are additional methods like find, replace, which are dedicated for text operations, but from the point of from dynamic data structure perspective, vector and strings are the same. So I showed you that we can represent vectors or we can represent any set of data using vector and list, and we can use similar or even the same methods to access these elements. So the decision which dynamic data structure should be used is dependent on the way how we are going to use it. So first principle, by default we use vector. Yeah, so if there no reason to use list, you should use vector. For vector, we can use pushback or emplaceback to increase its size. I showed you that this is quite efficient because STL pre-allocates more elements than we need. So we have to enlarge the vector not in every step. So this is the first. We have also insert and erase in a vector, but they are not so efficient like for a list. Remember that vectors vector keeps its element in continuous memory, and for small vectors and for small elements, so the elements which are smaller than, let's say, 12 bytes, all operations for vector are faster than for list. So a reason to use list is that we want to insert elements on the front, or we make or we add elements quite often. So we modify list. Let's say in every iteration we add an element. So in this case, the list should be considered. And when we change elements position, or we insert or erase elements from list, and the size of elements is larger than 12 bytes, let's say. Now, or maybe not now, but in a moment, I will tell you something about other containers like maps and unordered maps, so dynamic binary tree and hash tables. When we use STL, usually the header files which are enumerated here are used. So IOStream, I think you are familiar with it. Fstream, so this is header file which let us to perform input-output to file. Algorithms, so I will tell you something about algorithms in a moment. Numeric, so numeric algorithms, string vectors. Okay, you know what it is. Map and unordered map. So when we are going to use binary search tree or hash table, we should use this form. Okay. So now I'd like to tell you something about map. Last week I showed you an example how to implement binary search tree from scratch. Okay. So here we have an example how to implement tree from scratch. And now I'd like to show you how we can implement this using STL. So look. Okay. Okay, so I take this piece of code and I'd like to show you how we can convert it from standard or from this way into STL. Hash include fstring. Okay. So first I'd like to show you how we can handle with maps. So binary search tree in STL is represented by container which is called a map. Yeah? So I can create a map, and for map I have to specify two types. The first type is type of the key. So for example, in this example, the key was a string or character array. So key is variable or element which is used to arrange elements inside the tree. So when we want to order elements with respect to word, then my key will be string. The second value or type here is object type. So element value. So look, if we have three, not here. Okay. If we have binary search tree, it consists of two parts, yeah? Key and value. So the remaining part is value. For this implementation, my element was consisted of the word which plays the role of key, and frequency, which counts the number of occurrences. Yeah. So in this case, the value of this element will be frequency, so it will be integer. So let's specify it here. Okay, so now I'd like to add a single element to the tree. I can do it on different ways, but I think the easiest one is writing tree, and here let's say word. So some word equal 1. Then I can add another word, but I can write it also like this, plus plus. What does it mean? If there are no words in the tree, it is created. So a new node is inserted to the tree and it is incremented by 1. So when I run it again, so I add this word again, it will not be inserted, but this element will be found and its value will be incremented by 1. So it should be 2. Okay, let's say that I add a new word and here. And now, let's assume that I'd like to print the tree or display all elements in tree. So I can use it using the method so using range-based for loop. So for example, auto reference element 3. And now, what is the element here? The element is a pair. So I have first and second attributes. So the first refers to key value. The second refers to value of element. So if I write cout element first, it means that a key will be taken. So some word, another, or and, yeah? So first, and then I can element second. So I can print the number of occurrences, so the frequency. Yeah. So let's try to run it. So look, another word and some word. You can see that it is sorted alphabetically because this is binary search tree. So all elements are inserted with specific order. So therefore, it is printed in alphabetic order, not in the order as the elements were inserted to tree. Okay, so now I'd like to use this method in my program. So I don't need to have node root. I have container tree. So I open the this file, and now I need to string word. And finally, I have to write 3 word. So this is my key, plus plus. So this is the way how I can increment elements. So I add a new word. If it exists, okay, the node will be increased by 1. If it it doesn't exist, okay, the element will be inserted. So a new node will be inserted to 3, and it will be 0 plus 1, so it will be 1. Okay. Okay, so here, while okay, so here I need to print print all elements. So I take this code. Okay. So here I have the code which prints everything. So now running this code, you can see that it works the same like my previous program. Okay, so look, this code is very short. So it takes less than 25 lines, and it performs the same like this code. So I strongly encourage you to use trees. They are very useful. What about an ordered map? Okay, if I'd like to use an ordered map, I can do it like this. And you can see that it works, but the elements are not sorted alphabetically. Why? They are not sorted alphabetically, and they are not sorted, you know, with respect to the occurrence order. So, so if I use, for example, here vector, oh, maybe not. Okay, so are you able to explain why these elements are ordered in this way? Unsorted. But what does it mean unsorted? Because look, if I have license txt, okay, so look, it starts with license word. So I expect that the first element here, oops. Okay, I expect that the first element here should be license, but here is MIT. So what is why they are ordered on this way. I told you that not randomly, yeah, not randomly, okay. I told you that the elements in an ordered map, so an ordered map is in fact hash table. So look, in hash table, for every key, the hash function is calculated, and the value of this hash is is the index in my array. So they are ordered with respect to hash value. So MIT has the lowest hash value among all the words. And the NOR has the highest hash value among other words. Yeah, so remember that this is not randomly ordered because they are ordered, but okay, it's not so evident what is the order rule, yeah? Because the order rule is the hash value, and the hash value or hash function calculates its value, you know, that freedom and freedom with a single E has totally different hash functions. So they are, you know, there is a huge distance between them. So the same, look, NOR and MIT. Yeah? For us, in alphabetic meaning, they are not so far, yeah. But in this case, we can see that they are totally different. Yeah? Okay. So let's go further. So here you have an example of map. Okay. So now I'd like to tell you something about algorithms in STL. So far, I showed you how we can use containers, you know, to store elements and to print them or to insert elements. Now I'd like to show you more, you know, advanced features. So look, I'd like to tell you something about algorithms. So what are the algorithms in STL? They are not so, you know, advanced algorithm like, let's say, make a coffee. Yeah? They are very quite simple, but we can use it. We can use them very often. Okay. So we have algorithm, for example, to find element, to count the number of occurrences of particular value, or to sort elements or to copy them from one container to another container, or to copy only unique elements, or to merge, or to make equal range. So I will explain this equal range later on. So look, they are very simple. They used single or maybe nested loops, but we don't need to write loops to perform some action. So look, let's try to start from copy algorithm. Look here, every algorithm you have listed here has at least two arguments. So arguments which is denoted by B and argument which is denoted by E. So B denotes an iterator to first element which should be considered by algorithm. And E, it denotes the iterator to the last element, so the element after the last which should be considered. So we can see that the algorithm process data in a range from B to element before E. So let's try to do it. So let's assume that I'd like to copy elements from tree to vector. So let's create a vector with elements which represent a pair, key plus value. So okay, so I create a new container, and now I'd like to copy all elements from tree to dict. I can do it here by using dict and place back element. So I can do it in a loop. So I take the element from tree and I insert it to vector. Okay. I can't do it writing dict is equal to tree because these are two distinct containers. Yeah, so unordered map and vector are not the same. So I have to do it manually, but I can do it also using algorithm. So I can write copy, and I can specify tree begin. Okay, the first iterator to the iterator to first element, tree, and the iterator to element after the last one. And now I have to specify destination. So, and here there will be certain problem, but let's say dict begin. So look, I specify the place where the first element should be inserted. And copy, in fact, it performs this action. So for every element, it maybe not inserts, yeah, because it copies the value of every element to dictionary. But if you check CPP reference, and we print copy here, okay, you can find example. So it's worth to analyze this example, but you can find also that okay, I can't find it, but I'd like to inform you that dict has to be pre-allocated. So it should be resized before we use copy. So I should do like something like this: dict, resize, or reserve. It doesn't matter. So resize 3 size. So here I allocate the number of elements which are in 3, and then I can copy them without problems. So in case of copy, it doesn't allocate memory, so it doesn't call and place back or push back. So this is the first possibility. The second possibility is to use not dict begin, but how it is called? Insert iterator, and here dict. Not back inserter. Okay. So in this case, if I use back inserter, in when single element is copied, the pushback command is called. Yeah? So in this case, in every, let's say, iteration of this inner loop, the command is the pushback command is called. What do you think? Which of these two ways should be faster? Okay, so look, the faster is the method with resize. Why? Because we resize. Yeah. So we resize the vector once. So we have enough elements to represent all 3. And then we only copy values. In this case, we resize element not in every step, because you know that for vector, the resize policy is that it is resized by 2 times. Yeah. So if it has 2 elements, it is resized to 4, if it has 4 to 8, and so on. But it has to be resized here. So it takes more time, because if we resize element, we have to copy it all elements to new array. So it is slower. But here we don't need to know what is the number of elements. Okay. So here we have the copy algorithm. Now I can run sort. For dict, begin, dict, end. So look, I have another algorithm, which is called sort. So it can be used to sort elements in vector, because in unordered map or in map, we can't sort elements because they are sorted with respect to hash or with respect to key value. So in case of unordered map and hash map, there are no way to sort it. Yeah, but if we have vector, we can reorganize this element. So to do it, it's enough to call sort. In general, sort is implemented using a quicksort algorithm. And now, if we have sort, I can print dict. I can print these elements on display. So running this code, you can see that they are sorted with respect to the first element, with respect to key. Yeah? First element in pair, yeah? So with respect to key. How to do it, or how to sort elements with respect to value. So now I'd like to sort them and print the most popular word. So I'd like to sort them with respect to frequency. Look, here for some algorithms, you can find that there is additional argument denoted by P. P means predicate. So what is the predicate? Predicate, maybe I will go to the slide which I kept. So the predicate is a function or function object. I will explain what the function object is, which takes argument or arguments and returns bool. So it returns true or false. So the predicate can be used by algorithm to modify its behavior. So for example, when I have algorithm find if, so it looks for element for which the predicate returns true. So here I have the definition of predicate, and find if for every element in this range from begin to end, it calls odd. And if it returns true, it treats that the proper element was found. Okay. So when I have sort algorithm, I can define the predicate. So here I have, let's say, predicate, but this predicate takes two arguments. So it compares one element from array with another element from array and returns true when if the first argument is less than. Okay, so let's assume that I'd like to write predicate bool is greater. Sorry, is less than. Okay. And now I have to specify two arguments, arg1 and arg2. What is the type of these arguments? Sort function, you know from bubble sort, that sort function consists on comparing elements. Yeah? So I compare two elements and I swap them. So the type of this argument will be the same like what is the vector type. So here I have pair. So this is the first one, and the second one is also the pair. Of course, I should use const reference to make it faster. So remember to use reference for your arguments. Okay. And look, here I should tell the algorithm what does it mean that the first argument is smaller than the second one. So it should return true if the first argument is smaller than the second one. So I can write, for example, return arg1 second. So I'd like to order them with respect to frequency. Arg second is smaller than arg2 second. So look, it returns true if arg1 is smaller than arg2 and false otherwise. So let's run it. Okay, sort, and here I have to pass predicate, so only the name of this function. Okay, so look, elements are sorted not in alphabetic order, but in order with respect to frequency. And the most commonly used word is the. Okay, but look, here we have a number of words of the same frequency, but they are not sorted alphabetically. Yeah? Here we have redistribute, and here we have also. Yeah? So now how to sort them with respect to frequency, and if the frequency is the same, alphabetically. So there are two possibilities. If this algorithm would be stable, we can sort them alphabetically and then with respect to frequency. But quicksort algorithm is unstable algorithm, so I can't perform this method. But I can do something like this. I can verify the condition. Okay, if it's smaller, return true. But if it's equal, I should return arg first. So first is the word smaller than arg2 first. Okay. Otherwise, return false. So if they are equal, I return that the smaller argument is the argument with smaller the first part, so with smaller key in alphabetic meaning. So running this code, you can see that the elements of the same, say 21. Okay, I have also certain made prior received. So you can see that these elements are sorted alphabetically. Okay, there is other and variant before also, but the capital letters in ASCII array are before the lowercase. Yeah, so therefore you have here another words presented. Okay. So when we use predicate, we can modify default algorithm behavior. So by default, the algorithm sorts object, for example, when we have pair, with respect to first element. If we want to override this behavior, I have to define predicate. Okay, is of course, I can create another way. So I'd like to, for example, sort these elements with respect to, with decreasing order. So it's greater than. So here it's enough to change the comparison marks. And now, if I'd like to sort it in opposite order, it's enough to change predicate. So look, now the elements are sorted in decreasing order or descending order. Okay, but predicates has a limited limited somehow, so predicate functions, yeah, has limited, so some limitations. So let's assume that I'd like to okay, let's assume that I'd like to find words which has, let's say, 7 characters. Huh? So I'd like to find how many words here has 7 characters. So I can use a function which is called count, or algorithm count. If again, I take the first and the last, the iterator to first in the last argument, and okay, and as the third argument, I have to specify the predicate function. So it's bool 7 cars. The input here is a single value, and now I should return arg1 first length equal to 7. So if it is equal to 7, this algorithm returns true, otherwise false. And this algorithm counts the number of elements which are which has the number of words which has 7 arguments. Okay. So let's run it. Okay, the number of 7 grams is 368. But look, if I decide to have a function which works not for 7, but for defined, so any number of characters, so 6, 5, 8, doesn't matter. So I'd like to define the number of characters, okay, somewhere here. It is impossible because the predicate function has fixed list of arguments. So for example, for find if, I can have only a single argument here. For sorting function, I have to provide 2 arguments only. So there are no way to pass the additional argument here. Okay, of course, I can use global variables, but for this laboratory classes and for lecture, it is prohibited to use global variables. So I have to find another way to cope with it. The better method for predicates is using predicate function or lambda expression. I don't know whether lambda expression is defined here. Okay, this. So what is the predicate object? this is a structure or class. You know what the structure is, so it will be easier to n-grams. And here in this, for this object, I should have at least a predicate, so a function, which is called bool operator. It is called a call operator, and here I have to specify the argument. So inside this operator, I have to compare it with n, let's say, and n can be int, n can be a value here. So look, I have structure. For structure, in structure, I have a property and I have a function embedded. And this function reads, reads or gets the value of this property. So look now, when I'd like to call this this function, I can create n-grams Okay, I can do it in 2 steps or in a single step. So look. And now it's enough to pass the function 6 or the object. So I pass the object. Because this object has the function which looks like this, the predicate knows how to cope with it. So it calls this function, the same like the predicate function. Okay, so I can call it. So not n-grams because we have 6. It occurred 317 times. So now it's enough to modify my my structure, and you can see that it's 321 times, yeah, and so on. So we can call this function or this algorithm with different parameters. So here, using this structure, I can pass. Yeah, I can pass additional information. Huh? Of course, I can specify it, you know, like this in the runtime. So I can initialize it like any other structure. Okay. Comparing performance using predicate objects, they are faster than using the predicate function. Because this operator is not treated as a function, but it is, let's say, embedded into predicate call. So this code here is placed inside the predicate call. So this function, in fact, is not called. So the algorithm doesn't spend time to call function, to to freeze some stack parameters, to pass the arguments, to remember the return address, and so on. In this case, this function is called. So we spend more time to call this function. If we have many elements, this function has to be called many times, okay? So in general, this method is preferred over the standard predicate function. We have another way to create predicates. This way is the same. So the performance of this way is the same like functional objects or predicate objects, and it is called a lambda expressions. Okay. So lambda expression, what is the lambda? Lambda is the function which is defined in place. So it looks quite strange because we start with square brackets, then we have argument list. So the lambda function doesn't have name. And here we have the body of function. So let's try to write a lambda expression for this example. So I will copy it. And now, instead of defining predicate object or predicate function, I start with square brackets. Here, this element here is called a comprehension list, but okay, I explain it in a moment. Then I have to specify the argument. And finally, I have to copy the argument. And here I have a body of function. So look, here is my predicate function defined. So we can run it. So terminal is ready. You can see that it works. And now I'd like to tell you something about the comprehension list. On comprehension list, I can pass, for example, here I can create a variable or something like that. And on comprehension list, I can point out which variables from the scope has to be passed to this function, not using arguments, so like here, but they can be, they are accessible from inside of this function. So for example, I specified here that it is n. So now this n can be passed or can be accessed from inside of the lambda function. Of course, I can have more variables here. It's enough to separate it with commas. So look, when I run my code here, you can see that it works. So the question is when the lambda and when the predicate function or predicate object should be used. The answer is for short functions, you use only a single time. So they are created only for particular algorithm call. The preferred way is to use lambdas because okay, it's quite easy to analyze it. So I don't need to refer. So here I have to refer to external function to analyze what's going on here. Here in lambda, okay, I have everything visible. The performance of lambda expression and predicate objects is the same. So there are no difference in performance. But predicates object is, more flexible. You can specify here more elements at some another methods and so on. But the most important thing is that this operator should be defined here. Okay, so when to use a predicate function? So I suggest to use predicate function, when you start your adventure with STL. Okay, usually it's easier to understand the predicate function. So you can use it, but it is inefficient when we think about performance and when we think about flexibility. But as the first attempt to algorithm, you can do it. Okay. But I'd like you to know that there are another, let's say, better way how we can define predicates. Okay. Okay, here I'd like to show you an example of STL code. The very typical for STL code is that there are no loops in this code. So the number of loops is limited. Maybe not loops which are used behind the scene, but which are used by the user. So look, here you have something which is called an input-output iterators. So what is the input-output iterators? We can treat cout or cin objects as a source of data, so as a container which contains a number of words in case of cin, or cout as a container which can get a number of words. So I can associate cout with iterator. So I can create iterator, which, for example, so its name is OO, and the reference OO equal hello, it makes cout hello. Yeah, so I do the same using iterator. So OO++, it means, okay, get to the next word. And again, I can write a new word here. So you can see that these operations are equivalent, yeah, with cout. The same I can do with iStream. So again, the reference iterator will do the read word from CN. Then I get to another word, and again, I can read it. Okay, for this purpose, it makes no sense, but we can use it here. So here I create, I associate, I create two files, so two streams, which are connected with files. So input stream and output stream. And similar to output OStream iterator and eStream iterator, I create two streams. And then look, if I'd like to read all elements from particular another container, it's enough to specify the iterator to first element and the iterator to the last element. So look, for example, here, I can create a vector dict. So instead of using copy, I can define a vector dict, and I can specify the iterator to first and iterator to last. This call does the same what copy does. Okay. So here, this method is used. And then I sort the vector. And finally, I call unique copy. So unique copy copies only elements which are unique. So the repeated elements are not copied. You can find the explanation in CPP reference. Okay. So look, the unique copy copies elements from begin to end and write them to using OO iterator. So it writes them into file. So this code reads data from file, sorts them, and copies only unique elements and writes them into file. So as a result, we get a file which contains only a unique elements which are alphabetically sorted. So it's enough to understand how this iterators works. Okay. Of course, to this code we can make some modification. Here we change the container. Here we have vector, but we change it into set. Set is the same like map, but in case of set, we have only in a binary search tree, we have only a key. We don't have value part, and we have only a key. Yeah? So only single element. So in this case, when we get elements and we insert it to binary search tree, we don't need to sort them because when we insert element to binary search tree, it is sorted. And it is unique, so we don't need to perform unique copy. So there are no repeated elements, they are sorted. So finally, when I read it, I can simply copy them from the first to the last iterator to OO string. So here you have the explanation how set work. works. So I have only the key first, and behind the scene, I have two pointers to the left and right subtree. Okay, I explained how copy, how find if or count if works. The copy if works similar, so it copies only the elements which meet a particular condition. So for example, if I have count if, okay, I can calculate the number of occurrences, but I can copy if and here I should specify the, for example, vector yeah, and back inserted n-grams vector. Okay, so look, here I have copy if. So this is the source range from begin to end, and here I specify that the elements should be back inserted into this vector. And the condition is that the n-grams const par, okay. The condition is that only elements for which the lambda returns true should be copied. So only elements of 4 characters. So finally, I can here I can write n-grams vect element first, element second. So here I can print them. So you can see that here we have a list of elements which consists of 4 words. So hope you see that when we use STL, there is a lot of possibilities to perform some task in a very simple way. So using, several lines of code. Okay, the most important thing is to practice and practice and practice to be, to have higher skill in this. But what is the very important? So I started this lecture about STL from talking about generic programming approach. So look, the first feature of generic programming approach was our iterators. So we can perform this or run this algorithm for any kind of data and for any container. So here we can have a vector, we can have a tree or a hash table, a list, whatever. The second feature is that we can adapt this algorithm for different purposes because I can specify the predicate. So I can tell the algorithm what does it mean that, okay, this condition is true. Yeah? So the behavior is not fixed. Yeah? So I can modify it. So therefore, I have single algorithm, and I can use it on many ways, in many different, configurations. Okay, so it's worth to understand it, and it is worth to use it in your programming. Okay. Okay. In fact, in STL, there are a lot of predefined predicates, like plus, minus, less than, greater than. So you can use it. You can use them. You don't need to specify is greater than. Of course, in this case, when we have two-level comparison, you should do it. But for example, if you have a sorting algorithm and you want to sort algorithm in ascending or descending order, there are no need to use a new predicate. It's enough to write greater than, okay? And this predicate does this work, okay? Okay, so I think that's all for today. Tomorrow, we will be talking about text processing, so something which is called regular expressions. So how we can, extract some information from text. So how we can parse them and extract particular patterns. And tomorrow we will have, I think, two information engineering lectures. And after this time, I will switch to so tomorrow, I hope we will finish talking about STL and about programming. And from next week, we start talking about computer architecture. So hope we finish this block of topics tomorrow. Okay, so thank you for your attention, and goodbye, and see you tomorrow.